Hello, everyone. So we are gonna see how we can actually use angle sum identity for sine to prove the angle sum identity for cosine. Okay, so we do know the sine, like angle sum identity for sine was sine alpha times cosine beta plus cosine alpha times sine beta. Sometimes, like some people swap these positions, you can just write like the sine beta first and then cosine alpha after. The reason, like in some books, I would say writing this way, just kind of remember in the same format. So let me just write it as well. So cosine beta, and then plus, if you swap these, so the product doesn't change, so the sine beta, and then times cosine alpha. Like like in some cases, you can think about like just to remember in on top of your head easily. You can just say sine, cosine, cosine, sine. You know, you could go with that. Like the sines are the ones that is like starting and ending, the cosine are in the middle. You can just remember something like that. But in the second approach, you are seeing that I just start with alpha and then beta and alpha, so you can kind of see like the betas are in the middle, alphas are the outside. You can think about that as well. So that's why based on what reasoning that you are trying to use to remember these identities, so you can use either the first one or the second one. So, but I'm gonna go with the first one for now, but that's the second one is also okay. So this is something we actually prove two different ways. So you can take a look at those if you never seen. And the second thing we are gonna kind of use to prove our next identity is the some of the basic identities that we know. So if you have cosine of, let's say, pi over 2 minus some angle, okay, let's say this is data. When you have the like a right triangle, you can kind of imagine this is the case. If you have a right triangle and then the data is one of the acute angle, and then if you subtract data from the 90, you get the other acute angle. The cosine of one angle was equal to the sine of the other angle. So that is something we've seen in right triangle. But if the angle Q is not acute, so then that reason doesn't work for this identity either. But you can just think about as shifting cosine function like pi over 2, like in the x direction. So they will get the exact graph for the sine. So that is another way to think about why cosine like pi over 2 minus theta is the same as sine theta. Or the other way around, so if I have sine pi over 2 minus theta, that will be same as cosine theta. Okay, so you can use the same reasoning. So I want to use these as well as the sine identity that we derive to prove the cosine. So here's what I'm going to start trying. So our goal is to find another identity for the angle sum of the cosine. Okay, so this is what we are trying to do. But based on like this, I said cosine of the two angles, we don't have any identities yet. So what we can write, if I want to use the sine of the sum to get this one, I should combine this one and this one somehow. But if I want to get the cosine, but I don't know cosine, I need to use sine. So I need to start with a sine because I know the sine identity. So I can write this as pi over 2 minus some angle. I'm going to say this is alpha plus beta. So I hope that is really clear because, if you look at the second identity right here, so sine pi over 2 minus theta is cosine theta. So just imagine this parenthesis, your theta. So pi over 2 minus theta, when you take the sine for, you get the cosine of that angle. So that angle will be cosine basically data. But instead of data, I just write it as alpha plus beta. Okay, so this is what we just apply now. So as of now, we can go with this, but I'm gonna play with this a bit more. So because I like to take pi over 2 with alpha, so that could be written like the sine of pi over 2. If you expand this minus, you will get negative alpha. Actually, right? Actually, let's get started with the negative version. I am gonna do the positive version after, so I like to change this. Okay, so let's try the negative version. because the positive version is gonna be getting from the negative version. So let's say cosine, like angle difference of the cosine function. So that will give us like alpha, and then we had minus beta, right? And then now if you expand this minus, so you will get pi over 2 minus alpha, and then plus, because this negative will be positive, so that will be plus beta. And then that will be equal to this. So just imagine now, this is your one angle, and then this is your angle, second angle. So you have something plus something in the sine, which is this identity we can apply. It was telling us sine of the first angle that we start with, so that is going to be sine of pi over 2 minus alpha. So that's the this piece basically. And the cosine of the second angle, our second angle is beta, so that should be cosine beta. And then we are done with them. The cosine of the first angle, so I will go with cosine of this one, which is pi over 2 minus alpha, times, we just did that. And then the last one is the sine of the beta, which is second angle. Our second angle is also beta. And let's clean this a bit. Based on this, like sine pi over 2 minus theta was equal to cosine. So instead of this, I can just make that a bit better. So that will be cosine alpha, and then this is cosine beta. And plus the cosine of pi over 2 minus alpha or theta is equal to sine of that angle. So that should be just sine alpha. And then this guy will be sine beta. And now we are done with the proof. So the cosine, the angle difference between two angle difference identity for cosine is equal to cosine of the first angle times cosine of the second angle plus the sine of the first angle times sine of the second angle. So again, when we start with this negative, so the difference and in between those two products will be a sum. So keep that in mind. And by using this one, I will just now get another identity, which is cosine of the angle sum. So I'm going to use this guy, okay? So instead of alpha minus beta, or I mean, instead of alpha plus beta, I'm going to write this as alpha minus negative beta. So of the cosine. The reason why I do need to use this, let me clear this a bit. Because I do know how to deal with the angle difference of the cosine, right? So that's why I'm going to write this sum as difference. So that should be alpha minus beta. So now we can apply our identity. So in this case, I'm going to take this as my first angle, and then I'll take this as my second angle into this identity, which is this identity. So it says cosine of the first angle, which is cosine alpha, times cosine of the second angle, which is cosine of negative beta, plus the sine of the first angle, which is sine alpha, and the sine of the second angle, which is sine of negative beta. Okay, so if I clean this, so the cosine alpha is still as it is, but the cosine function was even. So if you remember, so just to remind, the cosine of negative angle, that was the same as cosine of that angle. But when it comes to the sine, or like any other function except cosine and secant, we said they were odd functions. So if I take this sine of negative angle, that was the same as negative version of the sine of that angle. Okay, so the cosine of negative beta is the same as cosine beta. Okay, so that's the thing. And the second part, this one is the odd function. So if you take the negative angle of the sine, so you will get negative of the sine beta. So that negative will be changing this plus to negative. So you should get the sine alpha times sine beta. And we are done. Like basically, we just use our sine angle sum identity and this basic relation that we had to prove the angle difference of cosine. And then by using angle difference, which we just rewrite this sum as difference and then apply the difference that we just got to get another identity. So these are some other identities that we are gonna kind of see and use it. So I highly recommend you to kind of take a look at the process and make sure you digest and go through this on your own and see if you can get these results. Because if you can do this on your own, that means you actually got the concept in general. And whenever you are not really sure about these identities, you can always use the same approach, even though it will take a bit time at first. But as you get used to, it will be way easier. So these are the two other identities that we just now discovered by using our previous identities. I'll see you in the next video.